Hi, this is Miwa, the real-time Discord Japanese voice translation. Let's begin with the problem statement. 200 million Discord users, a massive portion of serious gaming communities are Japanese-speaking. The current solution, Alt-Tab Paste Translate, breaks into a competitive context, and you're dead before you finish reading. But Miwa solves this. It's a transparent, always-on-top overlay that translates Japanese Discord voice calls in real time per speaker with AI reply suggestions targeting under 800 milliseconds end-to-end on AMD MI300X, so I never leave the game. For the live demo, I will show you how it works. So here's the real system. I'm in a Discord voice call with me as a acting Japanese speaker. Ohayo gozaimasu. The card appears in under 100 milliseconds, that's Google Translate, the fast packet. A moment later, the card updates Llama 3.3 with 70 billion parameters on MI200X, refines it to match the current style mode. This is the 2-pass split, perceived latency under 100 milliseconds, quality translation under 700 milliseconds. The user sees a result before they consciously process the delay. The Japanese words light up in sequence, karaoke highlighting driven by word-level timestamps, coming out of OpenAI Whisper, not token offsets, actual word boundary timestamps. Nihongo Benko Shiteru. 3 context-aware reply suggestions generated by a crew AI agent pipeline deferred so they never block translation from appearing. So we have these shortcut keys. Let's click one. And it will be sent to the channel and I can bot speak. Nihongo Benko Shiteru. So let's wait for the crew AI agent pipeline.
すごいね。すごいね。
As you can hear, it speaks and I can say I'll speak. And this is the Romaji pop-up, so I can read it myself. There's this reaction strip with 20 pre-written responses that switch per style mode. So these are the styles: formal, neutral, casual, and game. We can type wait in the search box. And it filters in real time. Each card delivers 2 ways, both sends to chat or bot speaks aloud in the voice channel through edge details.
え、マジ？え、マジ？
And it sends in the voice channel chat. For the calling for strip, if a non-Japanese speaker is in the channel, I can exclude them from the pipeline with one click, and their audio never reaches the AMD server. Without this, Whisper sees English audio and hallucinates Japanese text, garbage in and garbage out. Nihongo Benko Shiteru. So I disabled this and the card never updates because my audio never reaches the AMD server because I am disabled from the call info state. ずっと寝たかった. I wanted to sleep all day. So let's put this Miwa overlay into a real scenario.
オッケーオッケーオッケー。このゲーム久しぶりだね。
悪い私のミスだ。
マイバードマイバードです。何？
いや、水使ってるやつすごい。
うん。ああ。
わかる。
すげえ。すげえ。私言ってるのがもう、すげえ。
So after the video of the actual scenario with Japanese speakers, now I will explain to you the pipeline of Miwa. Latency budget, Whisper transcription, 150 milliseconds. Google Translate fast packet under 100 milliseconds, sent immediately. Llama 3.3 with 70 billion parameters, style refinement, under 500 milliseconds. Llama G5 milliseconds. total under 800 milliseconds. The 2-pass split is why it feels instant. The user reads the translation before the LLM even finishes. Suggestions: 1 deferred, never block translation from appearing. 3 agents, distinct modes. The analyst queries quadrant per speaker vector memory and reads the emotional register. The strategist decides the reply type, agreement, question, reaction, and game callout. The writer generates 3 style-matched Japanese replies. Each one is immediately pre-synthesized via HTTS, so bot speaks has 0 extra delay. So, why AMD MI300X matters for this system? Llama 3.3 70 billion parameters at full FP16 is 140 gigabytes. An H100 has 80. The MI300X has 192 gigabytes of HBM3. The entire model fits on 1 GPU. No quantization, no sharding. That matters for Japanese honorifics, register shifts. They live in the tail of the probability distribution. INT for quantization truncates that tail. Full FP16 is a quality requirement, not a hardware luxury. So for the system architecture, Layer 1, Node.js captures each speaker as a separate opus stream, mix the audio before transcription, and you lose speaker identity entirely. Each stream forwards over an SSH tunnel, 0 public ports, identical behavior in dev and production. Layer 2, AMD MI300X Whisper transcribe with word level timestamps. 2 pass fires immediately. VLLM calls go through a persistent TCP session. 1 reuse connection. Avoid 20 to 50 millisecond handshake overhead on every call. And for the layer 3, Tauri renders the JSON packet transparent always on top. Native Rust window, card updates in place on the refined packet. No render flash. For our engineering decisions, OpenAI Whisper not Whisper X, Tauri not Electron, SSH tunnel not a public WebSocket endpoint, per speaker opus streams not mixed audio, VLLM GPU util cap at 80%, Paikakasi not Mikab. So I'm Francis Daniel Menese, and this is Miwa, real-time Japanese voice translation for Discord, under 800 milliseconds on AMD MI300X.